Answer your question? Yeah? Okay. Couple of other things that you should note here is if more energy is released as bonds are formed than is absorbed as they are broken, then that means this will be a negative delta H, and it's an exothermic reaction. Okay. So let's take a look at what's at the bottom of your page. One more quick check. Okay. Why don't you take a look at the last quick check with the person sitting next to you, and let's see what you come up with.
Or and yeah. Which one? Wait, no. Combustion? It's negative. There's exothermic. Yeah. Yes.
Okay, dissolving potassium hydroxide is exo. How about combustion of propane?
Exo.
Melting ice.
Endo.
Replacement of iron by aluminum.
Exo.
And then formation of calcium hydroxide.
Exo.
Perfect. Let's take a look at the review questions. Okay. Indicate whether each of the following changes is endothermic or exothermic. Barbecuing a steak. Endo. Good job. Freezing a tray full of water to make ice. We disagree.
Endo.
Okay, so when you convert a solid to a liquid, it's absorbing heat. When you convert a liquid to a solid, then it must be what? Exo. Okay, so this would be exothermic. Okay, because you have to absorb heat to melt ice. So that means if you're forming ice, it's releasing heat, because it's the opposite. Neutralizing an acid with baking soda. Exo, because that's a neutralization reaction. Making a grilled cheese sandwich. Endo. Lighting a barbecue igniter.
Exo. Endo.
Endo, because doesn't it take a spark? Does that make sense? Okay. Condensing water on a mirror. Exo. Yeah. Okay. Any questions on those? Yeah.
So making a grilled cheese sandwich is endo?
Because it has to absorb the heat from, like, it's absorbing heat to melt the cheese and to, like, toast the bread.
I thought endothermic is when things like come together.
Endo is when it's absorbing heat energy. Okay. Okay, let's take a look at number 2. Does this potential energy diagram represent an endothermic or exothermic reaction? Endo. Okay. They want to know what the delta H value is for this reaction. Okay. So in order to calculate delta H, I'm going to put an R where the reactants are and a P where the products are. Okay. You subtract the two. So I'm going to look at where the reactants are to where the products are. So we're looking at this difference. This would be my delta H right here. Okay, so the delta H would be the potential energy of the product minus the potential energy of the reactant. So what would that be? What's the potential energy of the product? 450. What's the reactant?
300.
300. So this would be 150, and then you would get your units from the y-axis, which says kilojoules per mole. 150 kilojoules per mole. Okay. Any other questions on your one more, or is that it in your book? One more? Okay, let's take a look at question number 3. Let's come down here. They want to know what the delta H is for this reaction. You tell me. How would I calculate that? Product minus reactant. Okay. What's the potential energy of the product?
200.
Okay, 200. What's the reactant? 250. So what would this be?
Negative 50.
-50, and then what's my unit? Kilojoules per mole. Done. Okay. All right, your homework is actually on Canvas.